I would like to now invite Mr. M. Soundrakumar, Advisor, Sientra, to deliver a talk on use cases with potential for standards-based solutions. Something, something. Soundrakumar sir, C. has graduated from MIT Madras and also did post-graduation in technology management from AIMA, New Delhi. He has more than 40 years of rich experience in electronics, telecommunications, and networks. As Director Technology and C. board member, responsible for design, development, and deployment of cutting-edge technologies to Indian strategic network like security, defense, and projects of Ministry of Home Affairs, Department of Telecommunication, BSNL, MTNL, and Defense Networks. Mr. Kumar is currently Telecom Advisor to Sientra. Over to you, sir.
Good evening, everybody. I would like to thank TSDSI for this opportunity, and I would like to thank DOT for the support. And the last, it is like IPL. 6 balls, 30 runs we have to score. Okay, I appreciate all the audiences, some of the big faces and good faces from CDOT also. I would like to introduce myself. I was a former director of CDOT and taking care of this RAN activities in Bangalore, and I was a board member also. So during that time, we have developed this in 2014, IoT MTM. That is a standard we created at that time, and it was well supported by the DOT as well as from other sectors like a TSDSI. And we have developed this product with the view that, yes, we have to form a standardization body and we should be part of the standardization. Not only the product, whatever we develop, we should be as an international standard. Not only our product should be in India as well as abroad also. This is the motive behind this development. And I would like to present the key points in this talk. And basically, these are all the 2 things in the morning they talk about. One is the ubiquitous connectivity. Second thing is, I wanted to say that one, not only the connectivity, the security is also important in the IoT network, because when the network is increasing day by day, the number of devices also will be going up and up. And it is going to be in trillions. And we do not know how many devices will be connected, and the connectivity is an issue. So for that, we are taking care of this 4G, 5G, 6G, all those things. That is one type of connectivity problem issues will be solved. Second thing is, in the different network, in our Indian network, different technologies will be there, 2G, 3G, 4G, and 5G. So all those things, if it is 5G and above, it is taken care. If it is less than 5G, then how it has to be connected. So that is a main issue in the IoT network. So that is, we are going to discuss about it. And the second thing is the IoT security. And the third one is, it should be an international standard. It is as per the 3GPP standards. Finally, we have to adhere to the international standards. Why? Because it is not, our product should not only serve the people in India, it has to go everywhere and say that it is an international product developed by Indians and for Indians as well as for the global. See, this is the international standard. First of all, if it is a 5G sensors, IoT sensors, then it will go through the 3GPP access, then it will go to the core, and then it will go to the data network. Suppose if the devices, if the IoT device is not 5G, then it has to go to the non-3GPP network. And this is the issue where we are going to give the solution through which it is connected to the network in such a way that whatever the facilities like a slicing and quality of services, whatever these devices are supposed to get it, the same thing will be available to this devices also. Non-5G IG devices also will get all the facilities like authentication, slicing, as well as quality of services and things like that. So in the present network, this connectivity is the first connectivity, as I told you. If it is a NR, then straight away it is taken care. Sorry. If it is NR, it is taken care through this devices. It is connected to the 5G. Finally, it is through this N2, N3 interfaces, it is going to the 5G core, and then it is getting connected to the server. the vice versa, whatever the applications or all these things will be pushed back to this G-Node B through this, and then it is coming back to this edge devices. Suppose if it is not 5G, then it is going to be from this bottom portion. This, whether it is a Wi-Fi, LoRa or hotspot, whatever may be the interfaces, the connectivity interfaces, it will be connected to our solution. That is, this is a solution created by Cientra, and this is a unique solution, and it is a patented one. It is well accepted by all the bodies, like a DOT. They have seen the solution, and we are doing the field trial in railways, and we have shown this solution to in the Agriculture University also, with the INVAS is the IoT partner. Finally, our aim is to show to the world that yes, we have the solution for non-5G IG. That is, if it is a non-NR, that is, if it is not non-5G IG, then how we are taking care. So this is the solution we have developed that is internationally accepted, or it is as per the international 3GPP standards. And we are taking care of all types of connectivity problems. So another thing is the security problems. As I told you, the security problem is taken care if it is hooked onto this 5G network, so that whatever the authentication, these are all the mandatory things. First of all, it is supposed to be having a eSIM mobile number, and it should be authenticated. Presently, all the IoTs are not authenticated. That is the main problem in the, second thing is then this emergency services. Right now, whatever mobiles you have, all this SMS, everything is taken care. All these alert messages are coming. But whereas in the IoT, there is no such things are happening. So if it is going to be enhanced to this 5G, then you will be able to get and send and receive the messages from the IoT devices. And another thing is non-radio G-Node Bs should be connected with the APIs, and whether it is connected or not, where there is no coverage. For example, in the rural areas or any other place where there is no radio connectivity, then how will you communicate? Today, the practical problem is all the remotest villages should have the facilities, whatever it is. In CDOT, we have defined a solution that is up to panchayat. All these optical lines will be going to every panchayat through this BBNL. But even if there is no connectivity or RF connectivity, if there is no 2G or 4G, you will be able to connect it with this solution. That is what we have tried. And the last mile connectivity, even if it is not there, we have extended from last mile Wi-Fi 6. That is what we have designed in CDOT. Last mile connectivity will be through Wi-Fi to the villages, and it is backhaul could be, it is either it is a 4G or 2G or any other optical network. So even the remotest village will be getting all these facilities of 5G in this solution. And another thing is not only the all this unified dashboard. That is one dashboard, you will get all the information or status. And this is very, very important. Slicing, that is not available with the 4G or anything, because there is a major difference between 4G and 5G. 4G is built on the basic infrastructure which cannot be upgraded or anything. Whereas the 5G is built on the service architecture. Service architecture means today it's 5G, tomorrow it can be upgraded to 6G. That is the main important thing between the 4G and 5G. And apart from that, the slicing, the authentication, and the quality of services, all these things should be made available. So that is the requirement of a 3GPP that is possible through this solution, whatever we have developed through Cientra. Of course, small investment, and there will be a multi-tech connectivity options are available. That means any type of, whether it's a LoRa, or Zigbee, or anything, what is available, so that can be connected. Indeed. So this is what we are doing actually. IoT, 5G IoT, it is very clear. It is going to take that route. Suppose if it is legacy IoTs, so it is coming through the access network or edge, then whether what network is available, whether it is one connectivity is required, whether it is a Wi-Fi or 4G hotspot or LoRa, anything, it will be interfaced with the this gateways, LoRa gateway or 4G RAN or whatever it is. Once this is connected, then finally all these things will be aggregated in this place, and then it has to be interfaced through the standard protocols, the NAS protocol and all these things are all standard 3GPP standard protocols or the standards we follow. And here, this 5G IG, this IP G Node B, whatever we have developed, it is just exactly the same as this 5G RF G Node B. So this is the maximum advantage which does not require any spectrum. Today, this is the biggest advantage for the labs wherever the education institutes or any other standard universities are going to set up, or the private networks they are going to set up. You don't require a spectrum. Tomorrow, you install this IP G Node B, straight away you can upgrade this. I was doing an interaction with the MIT, Madras University, Anna University, where they are asking the same question. Sir, we don't have the spectrum. We cannot radiate. We require a permission. Then how do we think we can operate this lab? So this is the solution. We are giving it in the universities. That is, IP G Node B, you install it, whatever features available are possible, everything can be taken from this, because this IP G Node B is interfaced with our baby core, and then finally it is connected to any other core. It is interoperability is possible. Any other core, existing 5G core can be connected, so that all this authentication or slicing, quality of service, everything will be made available to these devices. This is the beauty of this solution. See, in the present scenario, these are all the network facilities available or various networks available. First case, some places or in the places, 4G is also available, 5G network is also available. So with the eSIM, they're able to communicate. Finally, they are converting into this 5G network is connected to the 5G core. And then finally, it is connected to the server and things like that. This is the first scenario. Second scenario will be, so separately, there will be only 5G. There is no 4G, but 5G is available. In that also, the internet is also possible. So both the network is also possible to be connected. This is the second scenario. The third scenario is there is no RF at all. That is no G. Okay. In that case, how will you do this? This is the remotest village I'm talking about. If the BBNL is extending the fiber to the last villages, that is possible to communicate at least. So this is the solution. We put our aggregator here and then transmit it through the internet. Then it is getting connected to the 5G core, any other core. So there is no RF connectivity is required. Then the fourth scenario will be wherever it is only 5G is available, and wherever this 5G through this aggregator is also available, the basic interfaces are available through this N2, N3 interfaces, and this is the 3GPP standard interfaces. Okay, yeah, coming back to this. Three use cases I would like to explain. One is railways, second one is agriculture, third one is the lab. First one is agriculture. Thanks to Invas is, we have formed a consortium. That is, IoT partner is Invas, and IP G Node B is developed and supported by Cientra. And G Node B, RF G Node B is also supported by Avalon, and 5G core is also available either from IIT Madras or any other core. So we formed a consortium and we can develop this complete solution. And recently I have included one more person and going to be included, that is Cosgrid. The cyber security or security is also going to be inbuilt into this consortium. so that we are going to give as a complete solution to anybody as a private network or in the public network also. So here, this Invas, all these IoT sensors are developed by Invas. They can have the wireless connectivity, and they can test the humidity of the soil, temperature, water level, sensors. Sensors are developed and it is communicated to the RF, any RF, signal, okay, lower R, Zigbee, or whatever it is. So it is communicated to this. This is the field node, that is the aggregator. For them, it is like a IP, AE to IP, data logger. Basically, it collects the data from the sensors, and then it is sent back to this Sientra solution. That is, aggregator of Sientra is sent. Then finally, it is processed here. Then it is through this C.CCSP, IoT, M2M, whatever C.dot has developed, we have interfaced with that, we have tested also. So whatever, it is an Indian standard and supported by TSBSI as well as DOT. So we have to adhere to all this IoT protocols and things like that platform. We have to use this IoT M2M by C.dot common service platform. Then finally it is connected to the other farmer's end application server. So this is the solution tried out. And the one good thing is more than we had a discussion with Agriculture University. There are more than 20 universities across India, and we are going to connect all these various universities through this solution, and we have to try out all these things. And already Invas have done the field trial in some places, and it is going to be a big hit for the agriculture society. In fact, agriculture society. We see it is not. I mean, we may be a technologist. Finally, whatever maybe I am developing, or the technology whatever I am developing, is it going to a common man? How he is going to be getting benefited? Don't see the return on investment. They are our backbone, and we have to make a solution. Technologists, we should have a solution or make a solution so that it is understood by them, used by them, benefited by them. If it is not so, then whatever we do, it is a waste. So I would like to tell you that rural first product, whatever we developed in C.dot, Rural Automatic Exchange. 32,000 exchanges have gone to everywhere in the villages. Finally, all the rural masses have been connected with the city. So here, the similar solution, whatever solution we develop through this IoT or 5G, it has to reach the nook and corner of the villages. Finally, it should be benefited to the society. And so similarly, this with the sensors, they are sending the data. Finally, from the application server, all this information will be fed back, whether to wirelessly use with a solenoid, we can control the motor, and then soil conditions. Based on the soil condition, water pump will be switched on or off, and then light will be switched on or off, and various other things. Another important thing we can do is with the drones, we can spray the pesticides, and with the camera built onto the drone, we can see the plants, conditions, and other things can be also viewed, and the data can be sent back to this aggregator. This type of another applications, they are trying it out. In future, we will be having this. So what I am trying to say is, whatever technology they have developed has reached the final goal of the farmers. With their mobiles, they can do anything. When I have to sow the seed, when I have to switch off the motor, and whether it is possible to control, everything is possible with the handset or the mobile. So that is a wonderful solution created by Invas. And another, we have done we are doing the field trial with the railways. Railways, basically, we have so many problems. One is the gates, whether it's closed or not, whether the track is closed or not, and there is a signal light, is it communicated or not, whether the train is coming in the same track or not. All these problems are there. You know that somebody tampered with the system, and then finally they do not know where is what. If it is authenticated, if all these things are all nothing but sensors. If these sensors are authenticated, if they are secure, and if it is connected to the network, so there is no other problems. Here, security is the main concern. You know that all these accidents are taking place because if the signal system is not okay, and it is controlled. See, basically, all those control systems are controlled in railways through signaling and telecom control systems and Kavach. So Kavach protocol, they use it. And here, what I'm trying to emphasize is all these IoT devices, these are all sensors, IoT devices are controlled, and it is coming to the Kavach server. Kavach server. Then the Kavach server will be finally connected to this railway network. And then the action also will be in the reverse way, whether it has to be closed or open and things like that. Okay. Here, IoT and security and authentication is very, very important. Nobody should tamper. At the same time, everything should be monitored centrally. So another thing is V2X also. V2X, that is vehicle-to-vehicle communication, the same concept is used. If the two trains are coming on the same track, which has to be identified, and it has to be communicated. So there will be a communication between the loco to loco, and loco to the station, and station to loco. And this is the lab setup, last lab setup. The first one is the regular 5G Node B and public core. These are all lab license we are recommending for the labs. And here, this complete end-to-end solution we are giving. So that means the flow will be from the sensors, it will be going to the aggregator. Finally, it is getting connected to the baby core. Final core will be connected to the servers and based on the applications. So the IoT vendor, they have to develop the application servers also, application for the servers, for the devices. So this is the setup we are going for this IoT labs. And just I wanted to tell you the August body, whatever 100 labs they have designed, which is not having the, sorry to say that one, this bottom portion is not there. It has to be standardized. In the country, we are making a lab and it has to be used by the students. They should have the facility and we should enable them with the technology. So I strongly recommend whenever any specification is made, so you make this G-Node B, RF G-Node B, as well as this IoT IP G-Node B also. It is essential. Without this, with this IP G-Node B, they can do all the experimentation, they can do all the lab activities also. So these are all the summary. This is the last slide. Summary will be, so my devices should be identified through IMI and or IMAC, or this unique SIM, eSIM we are creating, and then it will be in the server side, not on the device side. And this one is register and authentication. This is the most important thing. And identify the IoTs. Yes, it is possible. And we have to have the upgradation also from 5G to 6G, we can do it. And then legal interception. This is the most important thing. Government bodies, if they wanted to intercept anywhere, any device, they should be in a position to do that. And traceable, that is who has done this nonsense. So we have to trace this one. Today, news also was there. With the 5G mobile, they can identify the person who has done this nonsense. Finally, the mobile also will be tracked and it will be blocked and the person also can be hooked. So that is because of the authentication. So benefits, yes, whatever we discussed is fine. And this is the final, this one architecture. This is the alarm alert system we have created. So in general, what I wanted to say is two things are important. One is, yes, IoTs are many. We have to take the connectivity, ubiquitous connectivity, various networks are there. Ubiquitous connectivity is required. Second thing is, whatever devices you are connecting, it has to be secured so that no nonsense can happen, disastrous thing can happen, and it is our duty to enforce these two things in the standards. So TSDSI is the best place where we have to enforce this developmental activities as well as specification. It has to be made as a standard, Indian standard first, and then it is in line with the international standards, so that our product can sell not only in India, everywhere. Thank you so much for the opportunity given to me. Thank you.
Thank you very much, sir. I would like to now call Mr. N. Mohan Ram, sir, to provide a memento to Sundarakumaran, sir.